Today you're going to be using matrices to transform geometric figures on the coordinate plane. So let's do a few vocabulary words here. The pre-image is going to refer to the original figure before any transformation, and the image is going to be the resulting figure after a transformation. Then the last one I want to go over is dilation, and that's a transformation that enlarges or reduces the pre-image, resulting in similar figures. The size is the same, the shape is the same, but the size may be different. So we've already talked about reflections and rotations, and you're going to be doing some of those in this section as well. In order to do that, you need the transformation matrices. So that's what these matrices are underneath your vocabulary words, and you want to pay attention to clockwise rotation, counterclockwise rotation, how many degrees, if it's reflecting across the x, the y, or the line y equals x. All right, so let's go down. We're just going to start out real basic. We're going to start out with a dilation, and we're just going to increase a figure. And before we do that, I just want to caution you, matrix multiplication is not commutative, so you always want to multiply the transformation matrix on the left-hand side. So always on the left. All right, we're going to use this triangle ABC, given those three coordinates, and we're going to label the vertices of each triangle using ABC for the pre-image and A prime, B prime, C prime for the image. So after the transformation, the vertices are going to have these little marks here on them. All right, so let's start out. I kind of typed it out here for you, so there are three different things we need to consider. We have the dilation factor, which is 2. Now we need to set up what's called a coordinate matrix, and all we're going to do is take these points and we're going to write the x and y vertically this time, because that's how you need to set it up for your coordinate matrix. So we're going to write the x's and y's. So A has coordinate 2, 2, B has a coordinate of 1, -2, and C has a coordinate of -2, 1. All we need to do is, this is a scalar multiple. We talked about that in section 4.2. We're going to multiply each entry by 2, and that will give us the image that we're going to have. So everything multiplied by 2 is going to look like this. And to note that it's the image, we're going to use A prime, B prime, C prime. So when you go to graph it, there is our pre-image, and now we want to graph the image, and we have the points 4, 4, which is up here. That's going to be our A prime. And we have 2, -4, so 2 and -4. That's going to be our B prime. And then we have -4, 2. And it looks like I have my triangle shifted here. Okay, so now we're all set to, this is going to be my C prime here. And we're just going to connect our points. And there's our image. Okay, so you have your transformed triangle that's been dilated by a factor of 2. Pre-image needs to have ABC as vertices, and the image needs to have A prime, B prime, C prime. All right, let's do one more example, and then I'll have you do one problem on your own. We want to reflect the triangle PQR, and here are the coordinates, and we're going to label the pre-image ABC and the image A prime, B prime, C prime. All right, so again, we need to have a coordinate matrix, but this time, because we're reflecting, we need to multiply by a reflection matrix. We're reflecting over the y, so we're going to use this matrix here. That needs to be listed on the left-hand side. So here we go on the left-hand side. This is a 2 by 2 matrix. Our coordinate matrix, once we put the P, Q, and R in, again, we're putting them in vertical. All the x's go in the first row, all the y's go in the second row. This is a 2 by 3 matrix, so that means we can multiply. This says we can multiply, and this tells us what our dimensions of our new matrix can be, or will be. So it's going to be a 2 by 3. All right, I'd like you to turn the video off and try to multiply this out by yourself first, and then we'll see if our matrices match. Okay, I am going to show you the final matrix, or the image matrix, which is here. And what I would like you to do is, if any of these coordinates are not correct, go back to this where you can see the work for P prime, Q prime, R prime, and see if you can figure out where your error is. I'm going to go ahead and graph this at -2, 2. That's my P prime. And then -2, -1. That's my Q prime. And -4, 3. -4 and 3. That's going to be my R prime. It's kind of going into there, but I didn't have enough room to do all of this, so I kind of squished it into the graph. All right, so here is my image, and it has been reflected across, oops, went a little far there, reflected across the y-axis. Now you might just say, well, why can't I just flip the points? Well, the more complicated the transformations get, you're going to have to use reflections or rotation matrices and coordinate matrices. So I'd like you to get used to doing that. Preimages has vertices labeled A, B, C. Image has the vertices labeled A prime, B prime, C prime. Okay, so I'm going to have you try a rotation, and we're going to go clockwise, so make sure you get the correct rotation matrix.